Now let's take up question number 24. Here this question states that show that the altitude of right circular cone of maximum volume that can be inscribed in a sphere of radius small r is 4r upon 3. Also find the maximum volume of cone. So this is a 6-marker question related to the chapter of application of derivatives. Here we are talking about a right circular cone which has been inscribed in a sphere of radius small r. You need to show here that the altitude of that cone will be 4r upon 3. So let's consider that we have this sphere of radius small r and this is a right circular cone inscribed in this sphere. I am taking up altitude of the cone to be h and radius of its base to be capital R. Now observe here I have this radius as well as this h minus r, as total altitude is h, this portion will be h minus r, and here I have capital R. This is forming a right triangle. So according to Pythagoras theorem I get here this value of capital R, that is the radius of the cone, equal to square root of 2hr minus h square, because here capital R square plus h minus r whole square is equal to small r square. Simplifying that gives you the value of the radius in terms of small r and h. Now this will be used to obtain the volume of the cone. And how do we obtain the volume of a right circular cone? Its formula is pi by 3 r square h. So taking that into consideration, here instead of r square I will be writing the value in terms of small h and small r. So I get here v equal to pi by 3 2hr minus h square into h, where you further multiply h to these terms. This is the volume of this cone. So I am obtaining the volume of this cone as pi by 3 to h square r minus h cube. Now as we are talking about this right circular cone being inscribed in this sphere, where this right circular cone is of maximum volume. If this volume will be maximum, then dv by dh will be equal to 0. So taking that into consideration, here I have taken the derivative on both the sides. That gives me dv by dh equal to pi by 3 into 4hr minus 3h square. So next, if I consider this equal to 0 for the case of maximum volume, on simplification I get that 4r minus 3h into h is equal to 0. That helps me to obtain two possible values of h. So here this is a question related to the altitude of cone. You are observing that we are obtaining two possible values of h. H is 0 and h is 4r by 3. So here h is 0, I am neglecting that value, and let's consider here h is equal to 4r by 3. As this is the case of maximum volume, for that consideration I will be taking up d2v by dh square, and definitely that value comes out to be negative. If that is negative for this value of h, then definitely the cone will have the maximum volume for this value of the h. So for maximum volume, as I have told you that d2v by dh square will be negative. So obtaining d2v by dh square, I get here pi by 3 times 4r minus 6h, where I have differentiated dv by dh with respect to h. So here you can see this will be negative. If I substitute h as 4r by 3, what you will be obtaining? When h is substituted as 4r by 3, that gives me minus 4 pi r by 3. That is clearly negative. This means this is a case of having the maximum volume, and this is possible only when h is equal to 4r by 3. So I could definitely conclude in this case that for maximum volume, altitude of the cone will be, or it should be, 4r by 3. So you have seen how we have proved that the cone has the maximum volume and its altitude will be 4r by 3. Now after that, using this value of altitude, you need to obtain the maximum volume of cone. So I could write here volume of the cone was pi by 3 into 2h square r minus 3h cube. Let's substitute here h as 4r by 3. That gives me here 16 upon 9 r square into r cube, minus I have here 4 by 3 cube, that is 64 upon 27 times r cube, where you can easily simplifying this, and on simplification you obtain 32 upon 9 minus 64 upon 27. This clearly gives you the value of the maximum volume equal to 32 upon 81 pi r cube. So this is the maximum volume. So you have seen in this question, firstly we have shown that the maximum altitude of the cone having the maximum volume will be 4r by 3, and here maximum volume in this case will be 32 upon 81 pi r cube. So in this question, when you obtain this value of the radius of the cone in terms of small h and small r till this step, you will obtain 1 mark. Next, when you obtain the volume of the cone in terms of h and r, you will obtain another 1 mark. And next, when you obtain two possible values of h, that is 0 and 4r by 3, you will obtain 2 marks. Why we are neglecting h equal to 0? Because here this h equal to 0 means there is no altitude for the cone. Next, when you obtain d2v by dh square as negative quantity, here in this case it is clearly shown that h will be equal to 4r by 3 for case of maximum volume. Here you get 1 mark. And when you find the maximum volume of the cone, you get here another 1 mark, which gives me total 6 marks for this question. So here this is the final answer, 32 upon 81 pi r cube, and I hope this question is clear to you. Let's proceed to our next question.